In 1941, Adolf Hitler visited a secret testing ground in Rügenwalde to witness the firing of a weapon that defied belief. Before him stood a cannon so large that it blocked out the sun, casting a shadow that stretched across the entire facility. It was the Schwerer Gustav, a weapon that remains the largest caliber rifled artillery piece ever used in the history of warfare. It fired a shell the size of a small tank, weighing 7 tons, over a distance of 47 kilometers, with terrifying accuracy. On paper, it was the ultimate siege weapon, capable of smashing the strongest fortifications on Earth into clouds of concrete dust. But in reality, it was a logistical tumor that consumed the resources of an entire army corps to fire a few shots. This is the engineering audit of a gun that cost 7 million Reichsmarks but had almost zero impact on the war outcome. It is the story of how the Nazi obsession with size led them to build a dinosaur that was doomed to extinction. To understand the insanity of the Gustav, we must first look at the astronomical specifications that made this weapon physically unique. The gun itself weighed 1,750 tons, which is roughly equivalent to the weight of the entire space shuttle stack on the launch pad. It was 47 meters long and 11 meters high, a moving building made of hardened Krupp steel that dominated the landscape. It was so heavy that it could not move on a standard railway track because it would instantly crush the steel rails. It required a special double-track system, consisting of 2 parallel sets of railway tracks laid side by side to support the chassis. The gun carriage rolled on 80 massive wheels, distributed across 4 bogies to spread the immense weight over a larger surface area. The story of the Gustav begins with the Maginot Line, the line of impregnable French bunkers that Hitler needed to destroy. In the 1930s, Hitler ordered Krupp to build a weapon capable of punching through 7 meters of reinforced concrete without failing. Krupp engineers calculated that to do this, you needed a shell with a diameter of 800 millimeters, or 31 inches wide. By the time the gun was finally finished in 1941, France had already surrendered, rendering the weapon obsolete before its first shot. But having built the most expensive weapon in history, Hitler insisted on using it against the fortress port of Sevastopol in Crimea. Moving the Gustav from Germany to Crimea was a logistical operation that rivaled the invasion of a small country in complexity. The gun had to be disassembled into huge components and loaded onto 25 separate freight trains to travel across occupied Europe. But the gun was just the tip of the iceberg. The support network required to fire it was a logistical nightmare. To operate the Gustav, you needed a crew of 250 men just to load the breech and fire the massive projectile. But to support those 250 men, you needed 2,500 men to lay the tracks, dig the embankments, and build the infrastructure. You needed 2 dedicated flak battalions to protect it from Soviet bombers, plus a dedicated intelligence unit to select the targets. In total, firing this one gun required the full-time labor of over 4,000 men for weeks, paralyzing the local railway network. When the trains finally arrived in Crimea in early 1942, the engineers faced a nightmare of construction in the rocky steppe. They had to build a 1.2-kilometer-long double-track firing curve because the gun was too heavy to have a rotating turret. To aim the gun left or right, you had to physically move the entire 1,350-ton assembly along a curved railway track. It took 5 weeks just to assemble the gun and prepare the firing position, a delay that the Wehrmacht could ill afford. Finally, in June 1942, the order to fire was given, initiating a mechanical ballet that was both terrifying and incredibly slow. The loading process began with the 7-ton shell being hoisted by a specialized crane on the back of the gun breech. A massive hydraulic ram pushed the shell into the barrel, followed by the enormous powder bags needed to propel the projectile. When the Gustav fired, the ground shook like an earthquake for miles around, knocking soldiers off their feet in the trenches. The sound was so loud that the crew had to wear special ear protection and open their mouths to equalize pressure. The shells soared into the stratosphere, reaching an altitude of 30,000 feet before descending on the Soviet fortifications in Sevastopol. The results were terrifyingly destructive, proving that the engineering calculations of the Krupp family were absolutely correct regarding the weapon's power. One shell hit an undersea ammunition magazine in Severnaya Bay, which was protected by 30 meters of water and concrete. The Gustav shell punched through the water, through the rock, and through the concrete roof, detonating the entire ammunition dump instantly. It was a feat of ballistics that no other weapon on Earth could achieve, a triumph of brute force over geology. Over the course of the siege, the Gustav fired 48 shots at Sevastopol, destroying key forts like Stalin, Molotov, and Siberia. But then, the barrel wore out, because the friction of firing a 7-ton shell at 800 meters per second erodes steel. After just 48 shots, the accuracy degraded to the point of uselessness, and the barrel had to be sent back. Let's analyze the return on investment for this operation. 4,000 men employed for weeks to fire just 48 effective shots. That is roughly 80 men employed for weeks for each single shell fired. A ratio of inefficiency that is staggering to contemplate. A single squadron of Stuka dive bombers could have delivered the same tonnage of explosives in one afternoon for a fraction of the cost. And unlike the Gustav, Stukas could be redeployed to a different front in hours, providing flexible fire support where it was needed. The Gustav was stuck on its tracks, a prisoner of its own weight, and the railway network it depended on. After Sevastopol, the Germans planned to use it for the siege of Leningrad, repeating the exhausting process of transport and assembly. But just as the gun was ready to fire, the Soviets launched a counter-offensive, threatening to encircle the massive weapon. The Germans had to frantically disassemble the gun to prevent it from being captured, meaning it never fired a shot at Leningrad. It was a weapon that was always late to the party, too slow for the Blitzkrieg and too vulnerable for defense. Strategically, the Gustav represents the Maginot mentality in reverse. The belief that a single, massive technological marvel could decide the war. The French believed in static defense with bunkers. The Germans believed in static offense with giant guns, and both were wrong. The resources used to build the Gustav and its sister gun, the Dora, were staggering and could have been used elsewhere. The high-grade steel alone could have built dozens of Tiger tanks, which would have been far more useful on the front. The engineering talent, focused on the 800mm barrel, could have been used to improve the jet engine or the Schnorkel submarine. Why did Germany build it? Because of prestige, a vanity project for the Krupp family, and a propaganda tool for Hitler. It was designed to prove that German engineering had no limits, that they could build the biggest machines in the world. But engineering without logistics is just sculpture. A machine that cannot be effectively used is not a weapon, it is art. The Gustav was a masterpiece of mechanical engineering, but an absolute failure of military engineering, ignoring the realities of modern warfare. It ignored the iron triangle of tank design, firepower, protection, and mobility, scoring 0 in 2 of the 3 categories. The Gustav had firepower of 100, but its protection was 0 because 1 bomb on the tracks would render it immobile. Its mobility was 0 because it was essentially a building on wheels that required a dedicated army to move it inches. In 1945, as the US Army advanced into Bavaria, they found the wreckage of the Gustav scattered in a German forest. The Germans had used explosives to blow it up to prevent capture, leaving behind twisted shards of massive steel components. The American soldiers posed for photos next to the massive barrel, which looked like a tunnel they could walk through upright. They marveled at the size, but they also laughed at the absurdity of a nation that would build such a monster. The US Army had nothing like the Gustav because they didn't need it. They relied on air power and mobile artillery. The era of the supergun died with the Third Reich, replaced by the more efficient and mobile technology of rocketry. Missiles like the V-2 proved that you didn't need a massive barrel to deliver a heavy warhead over a long distance. A rocket carries its own propulsion, whereas a gun has to contain the explosion, making the gun exponentially heavier as it scales. The Gustav was the dinosaur at the end of the evolutionary line, the T-Rex of artillery, massive but destined for extinction. There is a psychological aspect to the Gustav as well. It terrified the people of Sevastopol who endured its bombardment. There is something primal about being shelled by a gun you cannot see or hear until the explosion destroys your bunker. But terror doesn't win wars. Logistics do, and the logistics of the Gustav were a self-inflicted wound on the Wehrmacht. While 4,000 men were playing with a giant train set in Crimea, The front lines elsewhere were collapsing for lack of infantry. The Gustav is the perfect companion to the Maus tank. One was too heavy to move, the other too heavy to aim. They are twin monuments to the Nazi failure to understand the concept of efficiency in a total industrial war of attrition. They sought the Wunderwaffe, the wonder weapon that would win the war in a single stroke, ignoring the laws of probability. But WWII was a war of averages, not outliers. It was won by the thousands of average Sherman tanks and planes. The Gustav was an outlier, a statistical anomaly that fired 48 shots in a war where billions of rounds were expended. It occupies a strange place in history, because technically it worked exactly as designed and did exactly what Krupp promised. It smashed the bunker and hit the target, but operationally it was a disaster that consumed more than it destroyed. It proves that you can be technically right and strategically wrong at the same time. A lesson for all future engineers. You can build the biggest gun in the world, but if you can't move it to the battle, it is scrap. So the next time you see a picture of the Schwere Gustav, don't just look at the size of the barrel. Look at the empty tracks behind it and think of the 25 trains that were needed just to move the components. Think of the 4,000 men waiting for weeks to fire one shell, eating rations and burning fuel while the front collapsed. It wasn't a weapon of war. It was a monument to waste, a symbol of a regime that valued size over sense. And like the Maus, its greatest contribution to the war was burning German resources that could have been used to kill allies. In that sense, the Schwere Gustav was one of the most effective weapons for the Allied cause, accelerating the German defeat. This gun stands as a permanent warning that, in the grim calculus of war, bigger is almost never actually better. The industrial capacity to build it existed, but the strategic wisdom to cancel it was missing in the Nazi leadership. The legacy of the Gustav is not in the targets it destroyed, but in the colossal effort wasted on a dream. It remains a steel giant sleeping in the history books, a reminder of the limits of engineering when divorced from reality.